Hello, this is Mrs. Boots, and we're going to work the practice problems for graphing rational parent functions. Number 1, let's first decide what the transformation is. So I have 3 different parts. Notice the 7 at the end is going to tell us that it's moving up because it's being added. The 3 is being added with the x, but remember it's inside with the x, so it's opposite. So we're going left 3. The 2 in the numerator is a stretch. So it's going to be 2 taller. Alright, so let's look at all of our qualities. The vertical asymptote is the h value, or the value where we moved it left. So this means our vertical asymptote is going to be at x equals -3. The horizontal asymptote is relation to our vertical transformation, the k value, where it moves up and down. So y equals to 4. So at x equals to -3 and y equals to 4, we have dashed lines. So I have my vertical asymptote, and that's not 4, that's 7. So we're going to go up 7. These are the asymptotes. Remember, these are not part of the graph, they're just guides in our graph. Alright? So now we're going to go through and actually write down our table. So look at where your vertical asymptote is. It's at -3. So we want to pick 2 points. We know -3 is an asymptote. Well, let's look at what's happening at -2 and at -4. Immediately to the left and immediately to the right. If I plug in a -2, in the denominator, -2 plus 3 is 1. 2 divided by 1 is just 2, plus 7 gives us a 9. So at -2, I'm at 9. Okay? At -4, plug that in, I get a -1, which makes that a -2, plus 7 gives me 5. So it's going to be at 5. So our curve goes through each of those points, doesn't touch the asymptotes, and is on our graph. Now let's look at our domain and range. Okay, so for the domain, we're including everything except that vertical asymptote. So remember, we're going from -infinity to -3. We put a parenthesis because of the vertical asymptote, and then from -3 to +infinity. Now let's look at the range. The range is going to stop at our horizontal asymptote. So we go -infinity up to 7. We do a union and we start up at 7 and go to +infinity. Again, both of those get parentheses. Now let's look at the last piece. Where is f of x less than 0? Less than 0. Okay, so 0 is the axis for y, and less than 0 would happen somewhere right in here, right? Because that arrow is going to keep going down. So it's going to happen from -4, because that's in between -4 and -3. So we would put that at -4 to -3. Number 2. Again, a parent function. First, look at the transformation. The 4 is a negative on the outside, so it's going down. It's going to affect our y's. The 1 is inside with the x, so we do the opposite. So we're going to go to the right. The 6 on top tells us it's a stretch. Remember, it's 6 times taller. So now let's look at our vertical asymptote. The vertical asymptote is whatever makes the denominator 0. So I could set x minus 1 equal to 0. Or I could just move right 1 and notice that x would equal 1. The horizontal asymptote, we moved what? Down 4. So y equals negative 4. Let's put those on the graph. So x equals 1. I have a vertical asymptote on the graph. That's our VA. And then at y equals negative 4, our horizontal asymptote. Okay, now let's figure out some points. So I know my vertical asymptote is at 1. So I'm going to do a few points just to get some plots. When I plug in 0, what do we get? The 0 is on the left. So I have 0 minus 1 in the bottom. That gives me a negative 6 minus 4. That would be negative 10. Then I'm going to do 2, and just for kicks and giggles, we'll do 3. So plug in 2. 2 minus 1 is 1. That ends up being 6 minus 4, which is a 2. If I plug in 3, 3 minus 1 is 2. 6 divided by 2 is 3. 3 minus 4 is negative 1. Alright, so let's put those points on the graph. So at 0, we're at negative 10. Well, that's way down here. Okay? At 2, I'm at 2. And at 3, I'm at negative 1. Oops. Three is negative 1. Okay. And then we could also plug in negative 2 and see that we're at negative 7. That gives us a good idea that our curve is going to come down, hit these 2 points, and then go out on the top and on the bottom. Fair enough? Alright, so let's look at what's going on. So, domain. What did we do? We go from negative infinity up to what? Our vertical asymptote. That's at positive 1. We do a U. We go from 1 to positive infinity. Our range goes from negative infinity to our horizontal asymptote, which is at negative 4. So it's negative 4 union negative 4 to infinity. Yes, we could have done the domain and range just by knowing the vertical and horizontal asymptotes, and we wouldn't have to draw the graph. But it's always fun to draw the graph. Now let's look at where our domain is for y greater than 2. So where is the y value of 2? The y value of 2 is right here. So where is my curve greater than that? That's only going to be right in here. What are the x values for that? Well, it goes from the asymptote all the way to 2. So we're going to say from 1, and that 1 is going to have a parenthesis to 2. And the 2 gets a bracket because it is equal to 2 at that value. Number 3. First do transformations. The 2 at the end is going to move it up because it's positive. The 8 is negative, but it's inside with the x, so we're going to go the opposite direction, to the right. The 3 on top actually has 2 transformations. Because it's negative, it's going to reflect, and the 3 itself is going to stretch. When would it be a compress? If that 3 is in the denominator. Now let's look at our vertical asymptote. Remember, it's whatever makes the denominator 0. So this would be at x equals 8. The horizontal asymptote is the same as our vertical shift. So that's at y equals 2. Let's put both of those on the graph. Y equals 2. There's our horizontal asymptote. And x equals 8. There's our vertical asymptote. Okay, Now that we've got those placeholders, we could go ahead and do domain and range. Right? Because our domain is going to be everything except the vertical asymptote. So I'm going to go from negative infinity to 8. And then from 8 to positive infinity. In my range, I include everything except the horizontal asymptote. So I go negative infinity to 2. And then from 2 to infinity. So no matter which quadrant my curve is in, no matter what points I use, I know it's not going to touch those two lines. Now let's look at creating a table. So notice the 8 is where the asymptote's at, right? So I'm going to do values of 7. We're going to skip the 8. We have 9. And let's do 11, just for kicks and giggles. So plug in a 7. 7 minus 8 is negative 1. Negative 3 divided by negative 1 is a positive 3. Positive 3 plus 2 is 5. So at 7, I can put a point at 5. At 9, 9 minus 8 is positive 1. Negative 3 divided by positive 1 is negative 3. Plus 2 gives me a negative 1. So at 9, I'm at negative 1. Now for kicks and giggles, I put 11 in there. 11 minus 8 is 3. Negative 3 divided by positive 3 is negative 1. Negative 1 plus 2 is positive 1. So at 11, it's at positive 1. So my curve is on the left-hand side of my asymptote on the top, and the right-hand side of my asymptotes on the bottom. Now let's look at the inequality. Where is my function greater than 2? Well, 2 is the asymptote, so I'm looking at everything above 2. Well, that would be just this top half up here. What's the top half? It's from negative infinity all the way up to 8, but not including it. Number 4. First look for the transformations. The number at the end being added or subtracted is the vertical shift, or K. It's positive, so it moves it up. The number inside with the X is the H, or the horizontal shift. Remember, it always does the opposite of the sign. So positive actually moves it left. The negative 1 on top is going to do two things. It's going to reflect because it's negative. Now we could say it's stretched, but really when you multiply by 1, it doesn't change anything. So in this case, it's only going to do one thing. It's just going to reflect. It will not stretch or compress. So let's figure out the vertical and horizontal asymptotes. Vertical asymptote sets the denominator equal to 0. So what makes the denominator 0? X equals negative 4. If I plug in a negative 4, the denominator is 0. Horizontal asymptote is always going to be at the vertical shift. It moved up 7, so it's at y equals 7. Let's put those on the graph. So at negative 4, I have my vertical asymptote. And at positive 7, we have a horizontal asymptote. Okay, so now for the fun stuff. Let's do domain and range. So my domain goes all the way up to what? The vertical asymptote, which is at negative 4. Goes around the negative 4 and continues to infinity. My range goes from negative infinity up to the horizontal asymptote, which is at 7. Goes around the 7 and comes on the other side to positive infinity. Now let's put those on the graph. Well, we need to put some points in our table to find it. At negative 4, we have an asymptote. So we're going to look at negative 3 and negative 5. If I plug in negative 3 in the denominator, I have negative 3 plus 4. That gives me a positive 1. Negative 1 divided by positive 1 is negative 1, and negative 1 plus 7 is 6. So at negative 3, I'm at 6. Okay, let's try negative 5. Negative 5 in the denominator gives me negative 1. Negative 1 divided by negative 1 is positive 1, and positive 1 plus 7 is 8. So my dot would be at 8. The curve is going to go through each of those dots. So on the top, I'm on the left-hand side of my asymptote, and on the bottom, I am on the right-hand side of my asymptote. Now let's look at the inequality condition. We're looking for anything greater than 4. Greater than 4. So I go to y equals 4. Where is it greater than 4? Well, that's pretty much everywhere except this spot right here. So we can't include that in our range, or in our domain. So we're going to go from negative infinity up to negative 4, go around it, and we're actually going to pick up at what? Negative 3. And go from negative 3 to infinity. We're only going to approximate on these. When you get to pre-cal, they'll get more exact. Number 5. Let's look first at our transformation. So the 3 at the end is the vertical shift. Because it's negative, it's going to move down. The 5 is the horizontal shift. Because it's positive and it's inside with the x, it's going to move left. The 3 on top is a stretch. Because it's positive, it's not going to reflect. The vertical asymptote is the bottom set to 0. So the value of x that makes the bottom 0 is negative 5. You could also say we shifted it left 5, so it would be at negative 5. The horizontal asymptote is at the value of k, or the vertical shift. So y equals negative 3. Let's put those on our graph. So y is at negative 3, and x is at negative 5. So I have my vertical asymptote and my horizontal asymptote. Let's write our domain and range. So the domain is going to go from negative infinity all the way up to the vertical asymptote. So that's negative 5. We go around the negative 5 and continue to positive infinity. So both negative 5s get parentheses. Now let's look at the range. We go from negative infinity up to the horizontal asymptote. That's at negative 3. We go around it and continue all the way to positive infinity. Now we're ready to plug some points into our table. Remember, we could have plugged the points into the table first and then done the domain and range. It doesn't matter which order you do these last few, as long as you've got your vertical and horizontal asymptote and your transformations done first. So if my asymptote's at negative 5, I want an x value of negative 4 and negative 6. I always pick points immediately to the left and to the right for my x's. So plug in negative 4. Negative 4 plus 5 gives me positive 1. 3 divided by 1 is 3. 3 minus 3 is 0. So at negative 4, it's at 0. That's right on the axis. Now let's look at negative 6. Negative 6 plus 5 is negative 1. 3 divided by negative 1 is negative 3. And negative 3 minus 3 is negative 6. So at negative 6, I'm at negative 6. So my curve comes in through those points. On the top half, I'm on the right-hand side of the asymptote. And in the bottom half, I'm on the left-hand side of the asymptote. Now let's figure out where f of x is greater than 0. 0 is the axis. So we start right up here, and this whole area is going to be above. Nothing else is above 0. So where is that? It starts at the asymptote. Remember, you cannot include it, so we're going to put that negative 5 in parentheses. And it goes all the way to where that 4 is at, or the 0. So I have negative 4, and I can put a bracket because we have the equal to symbol in our inequality. This concludes all of our practice problems.